dear students, today we analyze a continuous beam by slope deflection method. Now this is the continuous beam ABC subjected to UDL for AB span and subjected to point load for the BC span by the slope deflection method. Now in case of slope deflection method, the first step is to find the kinematic indeterminacy. That we call as Ki. That means Ki is nothing but the unknown possible displacement. So now for support A, so that support is a fixed. That is why here fixed support does not have any type of the displacement, so that Ki is equal to 0. Then the support C, again that support is a fixed support. So fixed support having the 0 displacement, so this Ki is also equal to 0. Now support B. Now this support is a roller support. So now roller support have the 2 displacement. For roller support have the 2 displacement. One is horizontal and second is the rotation. But here this is possible when there is axial force. So here we are neglecting the axial force. So consider only the rotation. That is why here Ki is equal to 1. What here? Neglect the horizontal displacement. Because here having the 2 displacement, one horizontal and second is the rotation, but this beam does not have any axial force. That is why this is the 0. So only the rotation, the displacement. So here total Ki is equal to 1, and that is the IB, and that is the IB, where only at the B support there is a possibility of the rotation. That is why only unknown displacement is the IB. At the A is a fixed end, so no displacement. At the C is no displacement. That is why Ki is 0. Only where the support B, here possibility of the rotation. That is why Ki is equal to 1, and that is the IB. Now the second step is to, if we write here step 2, that is clamp the each span and find fixed end moment. So now first consider span AB here. Now if you draw here figure like this, so clamp this both the ends AB. This subjected to UDL here 20. We know this UDL develop the fixed moment like this both the ends, and this is the M bar AB and this is M bar the BC. So here M bar AB is equal to, now this is what, anti-clockwise, so minus WL square by 12, and that is equal to minus 26.67. M bar BA is equal to, now this is rotation is a clockwise, so plus WL square by 12, So put value of 20 here, L is equal to 6. Now here L is equal to here given is a 4 meter and this is a 6 meter. So this is a plus 26.67. Okay, we have find out the now. Then the span BC here. Again clamp both the ends. Two meter and 4 meter. This point load we know is create both the side hogging bending moment. This is a B and this is C, so we call this as M bar BC and this called as M bar CB. Now M bar BC that we know, this is was anti-clockwise, so minus WA B square by L square, so that value is, or if you write here 100, 2 into 4 square divided by the 6 square, so that is equal to minus 88.88. And MCB is equal to here, this is a clockwise, so plus, we know the formula WA square B by L square. If you put the value of W right here, AB, so this value is equal to 44.44. This is also the kilonewton meter. So step number 2 is completed. Then next to step number 3. And that is the third step, slope deflection equation. Third step. So now again span AB here, right here I is equal to I, then L is equal to 4 meter. Now AB, so MAB is equal to M bar AB plus this formula is twice EI by L into twice IA plus IB minus T delta by L. Now here the only displacement is what? Is only the IB. So IA and IC is equal to 0. So this IA is equal to 0. Here delta is not given. Sinking of support is not here. That is why delta is the 0. So if you put the value of M bar AB is minus 26.67. Then plus 2EI by L is equal to 4 IB. So this final value is minus 26.67 plus the EIIB divided by 2. Then MBA. So here MBA. So you write the M bar BA. Then plus this is a common 2EI by L. Now first letter is B, so write here the twice IB plus IA minus 3 delta by L. So we know that IA is 0. Here delta is not given, so that is 0. So if this calculated final value is minus, this is what? The plus 26.67 plus 2EIL by 4 into twice IB. So this become 26.67 plus the EIIB. Then span, same procedure, span BC. Here I is equal to 2i, here is equal to 6 meter, and here delta is equal to 0. Delta is not given. So span is BC, so M bar BC, MBC. So MBC is here, so M bar BC is here. Plus, this is a common, twice EI by L. Now here starting point is B, so here twice IB plus IC minus C delta by L. So here we know that C, theta C. So theta is a fixed end, so that is 0. So this value is 0, this value is 0. So put here MBC is equal to minus 88.88 plus 2 into 4 EIIB divided by the 6. So this becomes into again here I is equal to 2i, so put here the 2, so that is why this becomes minus 88.88 plus 4 by 3 EIIB. Then MCB is equal to M bar CB plus, you know, here the formula twice EI by L. Here starting point is C, so here take twice IC plus B, so IB minus 3 delta by L. So we know delta is 0, IC is 0. So here is what, 44.44 plus 2E. Here I is equal to 2I, so here put 2I divided by 6 into the IB. So this becomes 44.44 plus 2 by 3 EIIB. So this equation number is 4, this is 3, this is 2, and this is 1. So here next step is to apply equilibrium condition. Now this is most important here, equilibrium condition. So always these conditions are always equal to the Ki, kinematic indeterminacy. Now here, how much Ki? Ki is 1, means we have to only apply the one condition where IB. So take sigma MB is equal to 0. If there is only unknown displacement which is IB, so take sigma MB is equal to the 0. So sigma MB is equal to 0. So now at the joint B, which are the moments? B to A and B to C. Always start from the B. So B to A and B to C. So we can say that is B to A plus M B to C is equal to 0. The always starting point should be the B. If you apply the sigma condition is sigma MB. So B from the B is only two moments, B to A and B to C. Okay. Then here put BA is 26.67 plus EIIB, and the BC is minus 88.88 plus 4 by 3 EIIB is all is equal to the 0. So this we got here EIIB is equal to 26.70. So put this value in equation 1, 2, 3 and 4. This 1, 2, 3 and 4. So here if you put the value of EIB in each equation, we'll get here the value sample. I calculate here for MAB only. minus 26.67 plus EIIB. Here put EIIB is equal to 26.7 divided by 2, so that is equal to 53.37 kilonewton meter. Now, in the same way, if you put this value, we'll get here the MBA is equal to this value is not 53, this is a minus 13.335. If you put the same value in BA, so this value is the 53.37 kilonewton meter. Then if you put this value in BC, in this equation here, EIB is equal to, so this MBC is equal to minus 53.29 kilonewton meter, and then MCB, here put your value, that value becomes, MCB is 62.24 kilonewton meter. What is here? We have to keep only this EIB in this equation, in this equation, in this equation, and in this equation. So this we got this value minus plus minus. So this BA and BC should be near about the equal. So this is okay. This 53.37 is nearly equal to 53.29. Then next step is to draw the BMD. Now how to draw this? Simple trick to draw the BMD. We know here this is the roller support. This is point load. This is the UDL. 20 kilonewton per meter. Now, here we MAB equal to minus 13.33. MBA, that should be equal to 53.37. Then MBC is equal to taken as minus 53.37 because both the value should be the same. And MCB is equal to plus 62.24. Now how to apply this moment here? Now this is the minus means the anti-clockwise. So here apply the anti-clockwise. MAB. Then BA is a plus means apply here the clockwise. Then BC is again minus, so apply here the anti-clockwise. Then last is C. CB is a plus. Plus means apply the clockwise. So here we have to draw the Bending diagram. First, consider each span as simply supported and draw the free BMD for each span separately. So we know here WL square by 8 here, and this point is here. This is the AB by L. So this is the 133.33 and this is the 40. Now we have to superimpose here the fixed end moments. Now this MAB is trying to push this upward, means create the hogging moment. That is why this create the upward side. Then MB2A, this is the clockwise, and this try to push upward means create the hogging. So show here that is 53. Then BC is again what? Pushing is the upward side. So it is the hogging bend moment. So put here the same point because both having the same magnitude. Then fourth one, MCB. So this try to again the push the upward side means hogging creating. So push this here above the line 62.24. So draw here. So you will get here this type of the superimposition of this is minus, this is minus, this is minus, this is plus, this is plus, this is 53.37, this is 13.33, this is 62.24. This is the final BMD of this problem. Thank you.